Okay, today we're going to be looking at a new topic within trigonometry, and it's called the sine rule. And the theory for this is following on from the area of the triangle, okay? Now, so let's talk about what the sine rule is first of all. The sine rule is basically a formula, and it's A over sine A is equal to B over sine B. And then for some reason they put in another version of it. They put in sine C. So it's A over sine A is equal to B over sine B is equal to C over sine C. Now, this is in relation to any triangle at all. It doesn't have to be a right angle triangle anymore. It can be any triangle whatsoever. So there's no right angle in there. But I know that if I'm talking about this angle here, A, well, according to my system from the area, I'm going to call the side opposite the angle A, small a. And similarly, if I put a big B there, let's put a small b up there. And if I put a big C up there, I must put a small c down there. Okay, so that's basically it. And then we can use these, and we can then use this formula up here to solve sides and angles and do all sorts of wonderful things, okay? So this is for every single triangle. It doesn't have to be a right angle triangle. Now, let's take a look at an example of what I'm talking about here. The example given in the book is something that looks like this. They have 62 degrees down here. They have 34 degrees over here. They have 12 and they have x here. Now, whenever I am faced with one of these questions, okay, it's always a really good idea to label up the angles. So if I call this guy here the angle A, I must call this x here small a. If I call the 34 degrees big B, the 12 here must be the small b. And then as normal in trigonometry, we're basically just filling into a formula. So there's two fractions, and they're equal to one another, and it's A, which is x, all over sine A, which is 62, and it's B, which is 12, all over sine B, which is sine of 34. As usual, I don't like doing trigonometry. I much prefer to be dealing in just straightforward algebra. So whenever I can, I put this type of thing here into my calculator. So I now have x all over the sine of 62 is 0.8829, let's say. And that's going to be 12 all over the sine of 34 is 0.5592. Now, that's quite interesting because we're no longer in a trigonometry question, now a straightforward algebra question, and we have one fraction equaling one fraction, so I'm allowed to cross multiply. So over on this side I will have 0.5592x is equal to 12 times 0.8829. So x must equal, 0.5592x equals 12 multiplied by 0.8829, which is 10.59. 48, and divide that. Oh no, I'm okay for the time being. To get x by itself, then I go 10.594 divided by 0.5592. So x is equal to 18.95. Right, so that's how we use the sine rule, guys. Basically, be aware of the formula and then label up your triangle. Very, very straightforward. Okay, so let's take a look at another one. if I take a look at question 1, part 1, and I might just draw my triangle again. I don't advise you to draw your diagrams in your Leaving Cert. It's 9. You could draw them incorrectly, but for me, talking about it, it's probably easier if I do draw it. So this is 68 down here this time. And this is 33 degrees. And we're asked to find the length of the side x. So we're going to use the formula, because it's a non-right angle triangle, we're going to use the formula a over sine a is equal to b over sine b. Now it will get slightly more difficult because you will have two different types of non-right angle triangle. So you'll have to make a decision. But for the time being, we only have one formula, so we know it's always going to be the sine rule. Now, in order to use this formula, I need to know what my A, my big A, my B, and my big B is. So I label up my diagram. Angles get capital letters, so if that's A, that must be small a. If that's B, that must be small b. Now I can put that information into the formula. Two fractions. It's a, which is x, all over sine 68 is equal to 9 all over the sine of 33. I can cross multiply, or I can evaluate the signs and all that sort of stuff. That might be the best thing to do first. Stick with our system. So sine 68 is equal to 0.927. And then we have 9, where we have sine 33 is equal to 0.545. Right, and then I might just move over to the right hand side. I'm allowed to cross multiply, so I can cross multiply this way. So I go 0.545x equals 9 times 0.927. So x by itself must equal 0.9. Do you know what? Again, I'm probably doing it a way that you guys wouldn't do it, so let's stick with the way I think you guys will probably tackle that. You will probably put that into your calculator now at this stage. So it's 9 multiplied by 0.927, which is 8.343 is equal to 0.545x. So x by itself must equal 8.343 all over 0.545. So x must equal 15.31. So the length of x must be 15.31. And correct to one decimal place, then that's going to be 15.3. So that's how to do that type of question. Now they can also ask the question when we're asked to find an angle. So if I just take a look at the other example they gave us. So this is example 2. And this was a triangle that looks like this. And we're told that this guy here is 53. And we're told this guy up here is A. And we're told that this is 14. And we're told that this is 12. And they throw in some other letters to try and confuse you. So we're going to label up the way we want to label it up. And I'm going to label it up. I'm going to call that guy there A. I'm going to call that guy there small a. I'm going to call this guy up here big B. And therefore this guy down here gets a small b. So the side opposite the angle gets the lowercase letter of the angle. So into the sine rule formula, that's equal. And it's 12 all over sine 53 equals 14 all over sine A. So it's B all over sine B, and my B this time was the uppercase A. I know that sounds confusing, but I deliberately didn't label that A to kind of show you that you impose the labeling system. Do not let the question impose the labeling system on you. Okay, you're in control of what gets labeled what. So as normal, let's get rid of that sine 53. So it's 12 all over sine 53. Sine 53 is equal to 0.7986 is equal to 14 all over the sine of A. Again, I have one fraction equaling one fraction, so I'm now allowed to cross multiply. So I write down 12 sine A is equal to 14 times 0.7986. I won't scroll down, I'll leave it up. I will now call that 12 sine A is equal to 14 multiplied by 0.7986, which is equal to 11.1804. So sine A is equal to 11.1804 all over 12. Sine A is equal to 0.9317. So to get rid of that sine again, guys, to get rid of sine on that side, so to get rid of sine on the left hand side, we do sine inverse on the right hand side. So A is equal to shift sine inverse of the answer, which is 68.7 degrees.